Okay, this is a presentation of the Integrated Math 1 Unit 6 exam. And for the first four problems, we're using the graph of segment AB over here on the upper right. And number one simply asks us to find the slope of segment AB. Well, you all know that slope is nothing more than rise over run. And to see that, many people like to draw a slope triangle into their diagram. You don't have to, but I like to do that. So if I'm going from A to B, I am rising 1, 2, 3, and I am running 1, 2, 3, 4. So segment AB has a slope of 3 over 4. We rise 3 and we run 4. Now, number 2, find the slope of a line that is the perpendicular to segment AB. Well, you need to know your rule about perpendicular slopes. Perpendicular slopes are negative reciprocals. So what is the negative reciprocal of positive 3 over 4? Well, negative means opposite of, and the opposite of a positive slope would be a negative slope. And then the reciprocal of 3 over 4 would be 4 over 3. So let me prove to you that this is correct too. All right. So what if I started at point A right here and I did a slope of negative 4 over positive 3? We're rising negative 1, negative 2, negative 3, negative 4, and running 1, 2, 3. So there's that slope right there. Negative 4, 3. And here's a point that would be on a line that is perpendicular to segment AB that goes through point A. Now, do you agree that that's a 90-degree angle right there? So that's the concept of perpendicular. You just have to understand lines that are perpendicular have slopes which are negative reciprocals of one another. All right. Number 3, find the distance between A and B, which is the length of segment AB. So let me clear some of this off, and we're looking for the length of this segment right here. We'll call that length C, like our friend Pythagoras did way back in the day. And notice that I left my slope triangle in the diagram because that creates a right triangle. And Pythagorean theorem says that in any right triangle, a squared plus b squared equals c squared. So let's go ahead and put this together. Now, what you need to understand is that A and B are the legs of my right triangle, and C is the hypotenuse of the right triangle, the distance we're trying to find. So I can use the 3 for my A, and if I square that, 3 squared, plus the 4 for my B, 4 squared, equals the hypotenuse of that right triangle squared, C squared. Now we're looking for C, so we have to take this equation and solve for C. So we'll show every step here. 3 squared is 9, plus 4 squared is 16, and that has to equal c squared. And now let's just simplify the left-hand side. 9 plus 16 is 25, so 25 equals c squared. And then to solve for the c, we have to take the square root of both sides of this equation. So I'm going to write the square root of 25 temporarily, the square root of 25, and that has to equal the square root of c squared. Now, if you know this square root, write the whole number. If you punch this out on a calculator and you get an irrational number, like a decimal just going on forever, just leave it written in radical form. So I think you all know that the square root of 25 is 5, because 5 times 5 is 25. But if you didn't, you could punch that out on your calculator. And the square root of c squared is just c. So the exact distance up here from A to B is 5 units. Now, number 4, write the equation of the line that is the perpendicular bisector of segment AB. Well, you need to understand that the perpendicular bisector of AB, all right, would have to be a negative, or excuse me, perpendicular bisector is going to go right through the middle of AB and the slope has to be perpendicular to the slope of segment AB. Well, let's put this together. We already have our slope of a perpendicular would be -4/3 up here. All right, so all we really need now is our midpoint. Okay, what's the midpoint of segment AB? Well, you can look at this and approximate it graphically. It looks to me like the midpoint would be, do you see my arrow? Right there. All right, and now I could approximate the coordinates of that point, that midpoint right now, but I'm going to make sure I get this perfect by using the formula for midpoint. Okay, and it's very simple. All right, what are the coordinates of point A? Well, the x-coordinate would be 1, 2, that's a -3, and the y-coordinate is a 1. And then the coordinates for point B, the x-coordinate would be a 1, and the y-coordinate would be a 4. Now, the midpoint, the x-coordinate of the midpoint would be the average of the x-coordinates of A and B. So what is the average of 1 and -3? Well, 1 plus -3 is -2. Divided by 2, I get a -1. -1 is the number right in the middle perfectly of 1 and -3. And now let's do the same thing with our y's. What is the average of 4 and 1? Well, 4 plus 1 is 5. 5 divided by 2 would be 5/2 or 2.5. So what we're saying right here is 2.5 is right in the middle of the numbers 1 and 4. So this would be my midpoint right here. Now, I have a midpoint of my perpendicular bisector, and I already have the slope up there. And because I'm not going to have a perfect, like y-intercept, I'm probably going to use point slope. I have a point, I have a slope. So let's go right to point slope right now. And point slope from last semester, remember, is y minus y sub 1, where y sub 1 is the y-coordinate of the point I'm going through, equals m, my slope of the perpendicular, times the quantity x minus x sub 1, where x sub 1 is the x-coordinate of the point we're going through. So I always start just like this. Y minus, and then what is my y sub 1? Well, that would be the y-coordinate of this midpoint right here, which we said was 2.5, equals, and now what's my slope of a perpendicular? Well, we answered that question in number 2. It's -4/3. And then x minus, all right, and what do we have right here? Our x sub 1, which is the x-coordinate of our midpoint right there, and that's a -1. Now, you could leave your answer like this, but I would prefer it if you simplify it a little bit. So essentially all I did is whenever I have minus a negative, I make it a positive. See, x plus 1 right there. And the -4/3, I did this so we could graph this real easily, but I like to write that with the negative out front, but you don't have to do that. So let's double check this now. So let's start at our midpoint C and do that slope of -4, -1, -2, -3, -4, and then let's run 1, 2, 3. And another point on my perpendicular bisector would be right there. So now I get my ruler out and I draw the line that goes through my midpoint and the second point created by our slope. And that is the perfect perpendicular bisector right there. Doesn't that look like a 90-degree angle? And the distance from A to the line is exactly the same distance as the line to B. And you guys could double check that with protractors and rulers too. So there's the first 4 problems on the test right there. That's really, really important stuff. Okay, now on the next section, which is a matching section, we do our transformations. So using the diagram below to match the image/pre-image listed on the left, right here, with the transformation listed on the right over here. Okay, and if you look at the transformations, all we have are rotations and reflections. So I'm going to give you a new tool so you can possibly recognize a rotation versus a reflection a little easier, because some of you are having trouble visualizing what we have, rotation versus reflection. So let's take a look at number 5, where the pre-image is shape 1 and the image is shape 2. Now, to me, this looks like I would have had to rotate to go from shape 1 to shape 2. Do you see how my right triangle looks like the shorter base is on the bottom standing upright? And it looks like it rotated. Okay, but here's how you prove it has to be a rotation. It's a concept called orientation. Go in the direction of your vertices, A, B, C, A, B, C. That is called a counterclockwise orientation. Now, look at the image of those anchor points. A prime, B prime, C prime. A prime, B prime, C prime. We still have a counterclockwise orientation. So if we have a counterclockwise orientation in both our pre-image and our image, then we must have a rotation. So counterclockwise orientation in both figures implies the transformation must be a rotation. So I know it's a rotation now, and I see there are 3 rotations over here in my transformations, okay? And each of them has a center of rotation of the point 0, 0. So now I'm going to put my center of rotation into my picture right here, and then I pick my anchor point in my pre-image, and I usually use the point closest to my point of rotation. So I'm going to use the C as the anchor point. Now, do you agree that the image of C in shape 2 would be this point right here? And we would call that C prime. Now, let's do a segment from C to the point of rotation, and then the point of rotation to C prime. And now look at this, okay? Now, that looks like 90 degrees to me, all right? And so I'm going to say that the 180 degrees is out. And I go to, oh, look at this, 270 degrees right there. Okay, so, interesting. Do you agree? Look at this angle if I'm going 270 degrees counterclockwise. Do you agree that that is 3/4 of a complete rotation? And if a complete rotation is 360 degrees, 3/4 of that would be 270 degrees. So that is a 270 degree rotation counterclockwise. So the answer to 5 is C. Very cool. All right, so let's go on to number 6. Okay, notice how I crossed out C over here in the transformations. We can't use any one of these twice. Although I believe with 270 degree rotations and 90 degree rotations, there may have been 2 possible transformations that work for the answer. But that's okay. As long as you're correct, I will give you full credit. Okay, so number 6. The pre-image is shape 2, and the image is shape 3. Great. Okay. Now, let's talk about the orientation again. See your A, let me see, A, B, C, A, B, C, A, B, C. This looks like we have a clockwise orientation. Now, A, B, C, A, B, C, this one is counterclockwise. So our orientations are opposite. So with opposite orientations, that means it must be a reflection. So I already know it's a reflection, and there are only 2 possibilities, B or D. So let's graph our line of reflection, y equals -x. Okay, yeah, we better pick now, okay? So here is my anchor point, and we're going to call that point C, and the image of point C over here in shape 3 would be right there, and we're going to call that C prime. Okay, now if I reflect C over the line y equals -x, would it end up at C prime? Well, let's graph y equals -x and take a look. So we draw the segment from C to C prime, and then we're thinking y equals negative x. Well, y equals, all right, now some of you struggle graphing y equals negative x written like that, but if we think about negative, can I write that as a rise over a run? And isn't negative the equivalent of negative 1 over 1? You see right here, those ones would cancel, and there's my negative x. Plus, and there's no y-intercept there, so it's plus 0. So let's go ahead and graph this line. The y-intercept is 0, and the slope is a rise of negative 1 and a run of 1. Right there, and there's my line right there. Y equals negative x. Beautiful. Now, does that look like y equals negative x is the perpendicular bisector of segment C, C prime? Well, would this have to be a 90-degree angle right there? Yes. All right. And we'll think about the distance, C prime to the line versus the distance from the line to C. Those look equivalent too. So guess what? The answer to number 6 is B. Okay. Let's move on to number 7. So the pre-image is shape 4, and the image is shape 2. Okay, let's think about our orientation again. Picture your A, B, C, A, B, C. We're going counterclockwise. A, B, C, counterclockwise again. So we have counterclockwise rotation in both the image and the pre-image. That means we have another rotation. All right. So let's label our anchor point and our center of rotation and the image of our anchor point. So center of rotation has to be the origin. And let's use that C again for our anchor point right there. We'll call that C. And in shape 2, that image would be this point right there, C prime. And now we draw our segments from C to the point of rotation, and then from the point of rotation to C prime. And that looks like a real good rotation to me. All right, so this one, let's see. Does this look like a 90-degree angle again? So 90 degrees, but we're going now in a counterclockwise direction. So let's see. 90 degrees counterclockwise, that's E. Awesome. All right, now 2 more to go. Number 8, the pre-image is shape 1, and the image is shape 4. Okay, let's think about the orientation stuff. A, B, C, counterclockwise. A, B, C, counterclockwise. So they're both counterclockwise, so we have a rotation again. Okay, now there's only one rotation left, so I'm thinking the answer is A, but let's prove it. Okay, so we're going to rotate about the origin again. And then our anchor point in shape 1 will be that C again. And then the image of our anchor point in shape 4 would be that point right there. That's my C prime. And now you draw a segment from C to your point of rotation and your point of rotation to C prime. And look at this angle right here. Does that look like 180 degrees? And notice, rotated 180 degrees, they don't have to give you counterclockwise or clockwise because it's the same either way when your angle is 180 degrees. So the answer to 8 is A. And then finally D. Well, there's only one answer left, but I'm going to double check this. That will help me with my confidence on the previous lessons if this is correct. Okay, so number 9, the pre-image is shape 1. And the image is shape 3. Okay, now I want to know, is this a reflection? Well, let's look at orientation. A, B, C, that's counterclockwise. Now down here, A, B, C, that's clockwise. I know it's a reflection because my orientations are opposite of one another. All right, so that looks good. Now, is it, though, a reflection over the line y equals 0? Well, you know y equals 0 is the horizontal line where every y coordinate is 0. So that would be, let's label C, C prime. And now let's go for that y equals 0. Right there, y equals 0. Now, does it look to you like C has been reflected over our line to end up at C prime? That looks perfect to me, because that is a 90-degree angle right there, a horizontal and a vertical. So 90 degrees, we're all good. And the distance from C prime to the line and the line to C, those would be equivalent distances too. So the answer to 9 is D, and that is the matching section for transformations. Really cool stuff. Okay, now perform the requested transformations. Make sure to label A prime and B prime. Okay, so reflect over the line y equals -1. Well, remember on the last problem, y equals 0 was this horizontal line right here. Wouldn't y equals -1? Y equals, you know, it's horizontal. So y equals -1 would be that line right there. And I love reflecting over horizontal and vertical lines because it's so easy. So let's take A and reflect it over that line. Well, A is 2 units from the line, so let's just go 2 units farther down. And there's my A prime right there. B is 1, 2, 3, 4, 5 units away from the line, so let's go 5 units farther down. 1, 2, 3, 4, 5 right there. There's my B prime, and there's my segment A prime, B prime. Nice. Okay, now rotate 180 degrees around the point 0, -1. So first, we have got to be able to plot that point. 0, x equals 0, y equals -1, right there. Now, rotating 180 degrees, I love a 180-degree rotation because all I need to do is take my anchor point, point A, and let's find the slope from A to our point of reflection. Might even do a little slope triangle right there. Does it look like we are dropping 2 and running 3? So now for 180 degrees, we just apply that slope from our point of rotation. So let's drop 2 and run 3 again, and see this point right here? That is A prime. And you notice A prime, that's a rotation of 180 degrees right there. Now let's do the same thing with our B. So B to the point of rotation, and I'm going to do my slope from B. So I'm going to start with my rise of -1, -2, -3, -4, -5, and then I'm running to the left, so I'm running -1. Now let's apply that slope one more time from the point of rotation, and we get our B prime is right there. All right, so now I connect A prime and B prime, and there you have it. A prime, B prime is the rotation 180 degrees about the point 0, -1. Perfect. Okay, number 12. Reflect over the line y equals x. Now you all know if you can't graph that line y equals x, you can't do the rotation, right? And most of you know that this is the perfect diagonal going through the origin, all right? But let's rewrite that 1x right there. Can I write 1x as 1 over 1? And then there's no y-intercept there, so that's a +0. And now I'll plot my y-intercept of 0 and apply the slope. I'm going to rise 1 and run 1, and then break out my ruler and draw my line. And now I am ready to reflect. Now remember, the definition of a line of reflection. A line of reflection would be the perpendicular bisector of the segment that connects A and its image A prime. So we first start with the concept of perpendicular, which the slope of my line of reflection is 1 over 1. So those segments have to be negative reciprocals of that. And what is the negative reciprocal of 1 over 1? Well, 1 over 1 is positive. So I'm going to make this a negative. And then what's the reciprocal of 1 over 1? It's still 1 over 1. So let's go from point A and apply that slope. I'm going to drop 1 and then run 1. Well, I'm not quite over the line yet, so let's do it again. Drop 1 and run 1. Now I'm on the line. Oh, that's perfect. That means if I do that slope 2 more times, drop 1, run 1, drop 1, 1, run 1, and that right there will be my A prime. Okay, now I'm applying the same slopes to my B up here. So let's drop 1 and run 1. I'm not quite to the line yet. Drop 1 and run 1. Now I'm beyond the line, but I'm not far enough, so we better do that one more time. Let's drop 1 and run 1. And look at that right there. That looks like my B prime. And you could check with a protractor and a compass, and yeah, not a compass, excuse me, a protractor and a ruler, all right? And, oh, I forgot my segment there too. Anyway, make sure you draw the segment in here. They'll probably come in a little bit later. I think my transformations are off a little bit. Anyway, let's go on to number 13. Draw the line of reflection. So now that maps P onto P prime, then write its equation. Okay, so I'm going to start with a segment from P to P prime. Oh, there's that segment I was looking for over there. Okay, here's the segment from P to P prime. Now you guys know that a line of reflection has to be the perpendicular bisector of that segment right there. So what do we need again? We need the midpoint of that segment and we need the slope of that segment. So the midpoint, okay, well, again, point P has coordinates -1, -2, and then 1, 2, 3, 4, 5. And P prime has an x coordinate of +2, and then y is +2. And now the midpoint, well, what's the average of 2 and -2? 2 plus -2 is 0. 0 divided by 2 is 0. 0 is the number directly in between -2 and +2. Now, what is the average of 2 and 5? Well, 2 plus 5 is 7, and 7 divided by 2, you could write as 7/2 or 3.5. So 3.5 is the number that is perfectly in between 2 and 5 on the number line, right there. So we're going to say our midpoint is x is 0, 1, 2, 3, and y is 3.5 right there. Oh, that looks perfect. Okay, so we have our midpoint. All we need is a slope. Okay, and what's the slope of our segment? Well, that is -3, +4. Now, the slope of a perpendicular bisector would have to be a negative reciprocal of that slope. So negative reciprocals, well, what is the negative reciprocal of -3/4? -3/4 is negative, so I have to be positive, and then the reciprocal of 3/4 is 4/3. So now I have a slope and I have a point, and I'm not going to use point slope this time because the point I have happens to be a y-intercept. So I'm just going to use, oh, we're checking this too. Let's make sure this works. That's a great idea. So I'm going through my midpoint, and let's do that slope. I'm rising 4, 1, 2, 3, 4. Note a little off the graph, that's okay. And run 1, 2, 3. Now get your ruler and draw that line. Does that look like a perfect perpendicular bisector? I love it. Okay, so now let's come up with the equation. Okay, so with this point and this slope, with this point being a y-intercept, we're just going to use y equals mx plus b this time. So y equals, and we decided our slope was 4/3 x plus, and our b is that 3.5 right there. And there it is, and that's a presentation of your test. This is a great test. I hope you're enjoying it as much as I am. Have a great day, and you guys let me know if you have any questions.